Hello and welcome to my class. My name is Teacher Foster. Alright, today we are looking at a question on variation. So let's go through and see how we approach question like this. So we are told P varies directly as the square of Q and inversely as the cube of Z. When P is 5, Q is 3 and Z is 1, we are asked to find the relationship between P, Q and Z and then find the value of Z when P is equal to 3 and Q is equal to 5. Now, this obviously we are talking about direct variation and inverse, so this is a joint variation question. Now let me take the first part. It says P varies directly as the square of Q. So this is the square of Q. And the second part, inversely as the cube of Z. The same P also inversely as the cube of Z. I'll combine these two equations. This is a direct variation, then this is the indirect variation. So I want to combine the two. This gives me P varies, this is squared over Z cube. So when I combine this is what I produce. Good. Now, this is my inverse sign, so I have to replace this with a constant of proportionality. When I write P is equal to Q squared over Z cube. Now I need to find the value of a constant K. I've been given the value of P and Q and Z, so I'll substitute that in here to be able to find the value of the K. Then I can establish the relationship. I would say that my P from the question is 5 is equal to K. My Q was given as 3, that's squared, over my Z was 1, so 1 cubed. Alright, so I'll cross multiply. This will give me 5 is equal to 9K. 5 because 3 squared is 9, so multiplying K, that gives me 9K. I'm interested in the constant, so I'll divide both sides by 9. My K, let me continue here. My K is equal to 5 over 9. I'm going to substitute the value of K into this equation to establish the relationship. I can say that, therefore, my P is equal to 5 over 9. But at the numerator level, I have my Q squared and I have my Z cubed. So that is the relationship. This answers the first part of the question. Now the second part, we have to find the value of Z when P is equal to 3 and Q is equal to 5. We have been able to establish this relationship. So all I have to do is to substitute the value of P and Q into this equation, and that will help me find the value of Z. So my P from here is equal to 3. I have 5 times my Q given is 5, which is 5 squared, over 9, multiply my Z cube. So I'll cross multiply. This should give me 9Z cube times 3 is equal to, this is 5 squared, which is 25, times 5. This should give me 27Z cube, and this should give me 125. Good, let's continue from here. It means that my Z cube will be equal to 125 over 27. Now I've been asked to find the value of Z and not Z cube. Now if this was squared, I would have taken square root. Once it is cube, I'll take the cube root on both sides. So cube root of Z cube will give me cube root of 125 over 27. This will take care of that. I'm left with my Z. Cube root of 125 is 5 and the cube root of 27 is 3. And this is the value of my Z. This is how we approach a joint variation question of this nature. I hope you have gone through with me. If you have any question, drop it in the comment section and I'll address it. Thank you.